So this video is for anybody who's interested in understanding how the methylation cycle helps us to produce our neurotransmitters, but also to regulate the levels of how much of them we have, and therefore our mood and our mood stability. So what I'm not going to be talking about here is all the in-depth pathways that are occurring in the methylation cycle. That can be for another time. This is just really looking at distinct points within the methylation cycle that are important for when we're making our neurotransmitters, and why it's important overall to make sure that the methylation cycle is working appropriately, and that we are supplying all the nutrients that we require in order to make it work properly, like, for example, methylfolate and methyl B12. So there are two things that I'm going to talk about here that require a functioning methylation cycle to produce. One is something called biopterin or BH4, and the other is something called SAM or SAMe. You might have actually seen SAMe as a supplement in health food stores. Often it can be given as a supplement, but these are the two things I'm going to be talking about. So I do apologize about the graphic here. It is very in-depth and there's a lot going on, so it's probably going to be difficult to actually see exactly the things that I'm talking about here, but I highlighted the different points. So I'll work through the different highlighted areas, so hopefully you can get a broad idea of what's going on and what I'm talking about. So in the red, this is biopterin. This is biopterin synthesis. And what we need to understand about methylation is it's the methyl groups that are produced within methylation, within the methylation cycle, provided to us by the use or the consumption of methylfolate, methyl B12, that will actually be able to produce this biopterin, which is essentially just BH4. And it's that biopterin that actually is used as a cofactor in order to take precursor amino acids like phenylalanine to produce dopamine and tryptophan to produce serotonin. So it's really important, number one, that the methylation cycle is working appropriately so that we have enough of this BH4 so that we can convert our amino acids, phenylalanine and tryptophan, into our serotonin and our dopamine. The next thing I want to point out here, and you'll actually see a little bit further down some yellow and some green. So what I'm highlighting here with the green is just the neurotransmitters that we're producing. So you'll see there first we've got dopamine, and then we've got adrenaline and noradrenaline. And as you may or may not know, dopamine is the precursor to adrenaline and noradrenaline. And why it's important to have these neurotransmitters is that dopamine is really important for drive and the seeking behavior that we require, and motivation essentially. And then adrenaline and noradrenaline do similar things, but they also help to provide the energy that we require for this, but also they're utilized, as you might already know, in the stress response. And so on the other side to the left, we then also have serotonin and melatonin. And what you may not know already, or you may, is that serotonin is the precursor to melatonin. So we can't produce enough melatonin if we do not have enough serotonin. And so what you'll see in the yellow is something called SAMe. And so SAMe is what we are producing. One of the main things that we are producing, and what the methylation cycle is seeking to produce, is SAMe. And it's essentially, if you want me to actually pronounce what it is standing for, it's S-adenosyl methionine. So essentially we've taken homocysteine, we've converted it to methionine, we've added on a methyl group, and then that can go to produce, and this is SAMe. And it's SAMe that is used as a cofactor to convert dopamine to adrenaline and then to noradrenaline, and in the same way serotonin to melatonin. So what I'm saying here in summary is that if we're not producing enough SAMe, we're not going to be able to metabolize these neurotransmitters once we've got them. What does this mean for our mood? Well, let's say that you have utilized the BH4 and you've produced some dopamine. You've produced enough dopamine, but you can't then convert it to your adrenaline and noradrenaline. You're going to have a buildup of dopamine, but we're not going to be able to produce the essential adrenaline and noradrenaline that we require. If we can't break them down properly, we're also then going to get a buildup of adrenaline and noradrenaline. So we're using things like COMT enzymes and MAO enzymes in this as well. And this is where SAMe comes in, and essentially we're trying to break them down. So once we make these neurotransmitters, obviously they do their effects in the body, but then eventually we don't want to have them just floating around constantly and just building up. We want to be able to actually metabolize them and get them out of our body, so that we don't continue to have this stimulatory effect. And this again is where SAMe comes in helping us to provide that methyl group so that we can break the neurotransmitters down for when we need them next time. And the same thing goes with serotonin. Once we've produced serotonin, we want to be able to metabolize it and produce some melatonin. And so we require that SAMe to be able to convert some serotonin to melatonin so that we can sleep well. And what people might notice if they are lacking in SAMe production is they might feel like they're overstimulated and they can't chill at the end of the day, they can't relax, they can't sleep. While there are other causes for things like this, more often than not, this can be an issue with not being able to supply enough methyl groups via SAMe to be able to break down those neurotransmitters once we've produced them. And like I said, if we're not able to, convert the serotonin to melatonin, then of course we're going to have trouble sleeping also. So I hope you found this interesting. If you've got any more questions on this topic particularly, please let me know. Before I do finish, the last thing I wanted to point out here that I think is just a really interesting note, and I think a lot of people don't know about it, is something where you will have brain on fire. That's what I like to call it, and that's what I've heard it being called a number of times. But if you'll see up to the top left in orange, there's something, I don't know if you can read it out, but it's called quinolinic acid. And it's a byproduct of where we can take serotonin and send it down, or tryptophan, and send it down a different route. So as I said before, if you recall, we're taking an amino acid called tryptophan and we're converting that to serotonin. And that's important for giving us mood stabilization, helping with reducing anxiety and things like that. That's what serotonin is there for, making us feel good essentially. If there are a lot of oxidative products and a lot of oxidative stress, not a lot of something called glutathione, which helps to break down those oxidants. Essentially, if there's a lot of inflammation going on, we can actually take that tryptophan and send it down a different pathway, which is called the kynurenine pathway. And you may not be able to see the ins and outs of this on this actual, image. But essentially what we're doing is, instead of sending it down to create serotonin and then melatonin, we're actually taking that tryptophan and making something called kynurenine and then eventually something called quinolinic acid. And this has shown to be quite, it can, affect neurons. It essentially is quite neurotoxic to our CNS. So something to keep in mind. Not only is it about producing these neurotransmitters and then being able to break them down via the methylation cycle, but also thinking about the things as well that can affect, our mood outside of the methylation cycle, and things that can slow it down, things that can speed it up, but also things that can push it down different pathways. And this is one of them. So instead of sending serotonin or tryptophan down to make serotonin, we're actually making something called quinolinic acid, which is neurotoxic.